So for this tutorial, I'm going to talk a little bit about bringing data from online sources, specifically from online APIs. APIs stand for an application programming interface. And the long and short of it is that it's an interface or protocol or a stable method in which you can grab data from a website online. So for example, one example of an API is City Bike's API. They essentially just host at this URL this file, which is in a format called JSON, that has all the City Bike stations and each City Bike station's location, their available docks, the number of total docks, latitude, longitude. So you can imagine that you could download this file and do some processing on it and bring it into Grasshopper and do something with it. And we'll do that in a little bit. You can also find other data sets such as the price of gold, and this is, I think, as I mentioned earlier in the earlier video, where the finding the data part actually comes in. In many ways, finding the data is the hardest part. Right now I'm using this website that I found called Quando that offers up different forms of data as APIs. And you may be lucky if you find that your information is freely available. You also might find that your information is not. So right now what I'm just going to do is I'm going to use this website's data download wizard, and you can see I'm going to use their API. And again, an API, you can think of it as like a stable format in which data will be given to you from a URL, from a website. And I'm going to take this aspect off since I don't want to trim it. I don't want to limit the range of my dates, and it looks like that was what it was doing. So now I have either this file or this file, and this is a JSON file, a file in JSON format, and this is a file in XML format. And I want to use either one of the two, either JSON or XML. XML because GHAL has a built-in XML reader, and JSON because I've coded a custom JSON reader that I'll share with you that can read JSON files. So what I want to do is then I want to copy the URL of my API, and you can see I already have one here, or perhaps the URL of this one, and I will bring that into Grasshopper. So that's kind of our data gathering step. We've gathered the location of the data. We've found it. And now we have to import it as a next step. Now, if you want to use JSON, there will be this Python component coded in Python, but it reads JSON files, or it grabs JSON files from the internet, and so you can either give it a URL, a path to a file, or actual text. And this activate triggers it on and off. And GHAL also has an XML reader, XML parser, where you give it a path of a file, so then you would have to download this and parse it in order to then read it, because I believe, it appears that you can actually give it a URL as well, and then you can see that as a result you get the list of values. List of values organized in according to a very specific tree structure. Very specific and very complex. Similarly, the Python component works very similarly. I'm going to plug a URL in, and I'm going to use the Boolean toggle to turn this thing on. And then also for look at the path, you can see that I have series of values for everything, series of IDs of what I'm looking at. So that's a way in which I can import the data. And the nice thing about using APIs is that this format will never change as long as the website never changes the format of their API. That's never supposed to happen. That's a big no-no in the world of making APIs. So if you have this file, you can be sure that unless something drastically changes on City Bike's end, you will always get this information in this format. So now the question is to process it. And it's sometimes a little tricky, and I'm going to give a little bit of an example in which we can mobilize JSON data and just kind of see what's going on and do a little quick visualization the same way we did the spherical representation with the text files. Right now, because if you notice that my paths are pretty complicated, I'm going to use a shift path so I can have everything under 1.194, 1.195 instead of having all these sub branches. So if I do that, then you can see it's already become cleaner. And sometimes this path shift gives me an error. It says path 0 is shifted out of existence. I think that's okay because path 0 is probably the topmost, the rootmost path, which isn't really crucial for our case. So now you can see all these lists of the IDs are what we're looking at. So we're looking at these are the IDs of the first station. These are the IDs or the what kind of values we're looking at for the second station, third station, and onwards. We can also do the same thing with the values. And so let's say we want to get the latitude, longitude, and the available bikes. So what I'm actually going to do is I'm actually going to use the list item component. And then I'm going to use a slider so that I can see, okay, I'm getting the latitude for this one. Getting the longitude for this one. And then I'm getting available bikes, the number of available bikes for this one. And since now we have these numbers and these numbers won't change, I'm going to put them in a text panel for for 310. I make sure to uncheck multi-line data, so each new line is a separate item on the list. That means I can plug this in here and get those values. And instead of getting the IDs of them, I can plug the values in and get the number 4, 3, and 10 from the values. So now you can see how they've properly updated to show me the latitude, longitude, and the number of available bikes at that point. Now there's a few things I can do with this. And actually, if you notice, well, for the convenience sake, I'm actually going to divide this into 2 chunks. Now these are a point. This is almost akin to a point. And what we may be able to do, we can't do that yet, what we would want to do is to reconstitute this into a point, and then we want to use Grasshopper's lat long coordinates to XYZ component. So if we want this, we want these to represent points. So I'm actually going to undo what I did earlier, or redo what I had done earlier. And then I'm going to use the XYZ component, or the construct point component, to construct, have the lat be the X value and the longitude be the Y value. So now you can see it's a little bit more, it's in a point format, which actually GHAL wants. And so we're going to plug this into the points. And then what else GHAL wants is it wants you to give the lower left and the lower right, upper right hand side corner of the map, and then the corresponding lower left and lower right hand side corner of the latitude longitude values. So let's actually say that we don't know exactly what we want, but we do know that we can calculate the bounds of all the point coordinates. And in doing so, figure out what our bounding box is so that we can figure out what the points are on the lower left and the upper right hand side corner. So I do this, I get a series of UV values, and I can deconstruct a domain. There's 2 deconstruct domains, and I want to deconstruct it into 4 numbers. And so this is the minimum latitude, maximum latitude, minimum longitude, maximum longitude. And so I can pair these together, actually, and get the minimum and the minimum of both values, the maximum and the maximum of both values. So then you can see that we have the lower left and the upper right hand side corners of the coordinates. Now the last thing to put in are the actual reference points, the points where we want them to go. Now what I'm going to do is I'm going to take advantage of our tool workflow, and I will make a separate layer, move this rectangle to that layer, and I'll grab that layer and any information on it. Great. Now this is so that we can kind of morph this map, and then all the points will change on demand. So I'm going to get the control points, and one little quirk, because this is a closed polygon, I end up getting 5 control points. So I'm going to use a create set function to reduce the duplicates now of the 4 points, and I'm going to sort the points. And the thing that this does is it sorts it in the x, y, and z directions in order. And because this box we're using is aligned across x and y, then we can use this sort point function, because we know that it's going to sort along the x, these two first, and then these two second, and then it'll sort along the y. So that means that this bottom left corner will be the first point, while the upper right hand corner will be the last point. So I can do that by getting the 0th item, and I can also do that because I've turned the wrap index on. I can get the negative first item, which will be akin to the last item. So now I have the first and the last points, and then I'm going to plug these into this component. So you can already see the points appear over there, which is wonderful. And it looks a little distorted. In fact, it looks like maybe left and right may have been flipped over at some point, at some crucial point. So let's look at that. Who knows, maybe that actually is correct. We are looking at the lower left-hand side corner, lower left-hand side corner, lower upper right. Same deal with over here. Lower left, upper right, but actually yep, this is still our lower left. This is our lower right. So this is a map of city bikes. And let's say, even though it's not super clear how the layout is working, let's try to actually color code these. So right now, I had the lat and longs. I also had the number of available bikes kind of extracted out. So what I'm going to do is I'm going to grab that data, see what it contains. Great, so it has all the numbers of available bikes. And I'm going to compare it against the structure of this geometry. Now it looks like they're fairly similar. So then I'm going to see if I can just actually use this geometry in a preview component, and then I will use I first need to convert this into a manageable scale. So these numbers, I'm going to remap the numbers, and then I'm going to use the bounds component to get a range of numbers, which which are going to be 0 to 63. So these are the values. This is the existing range, and this is the 0 to 1 is a new range that I'll get. So as a result, all my numbers have been turned into a fraction of a number between 1 and 0. So now I can use a color component to modify the color, and if I plug it into the preview, you can see that this shows us something interesting. And actually, you know what has happened is that it looks like it's been rotated. That's perhaps, or scaled too much. No, actually, I think that may be right. Seems like that's actually been taken care. Great. Oh, actually, I may have had the latitude and longitude switched. Ooh, yes, that looks much more accurate. So, okay, you can trace out the formation of Manhattan, and then parts of Brooklyn, and I believe parts of South Williamsburg here in this map. And you can see that the brighter points are probably the locations that have more city bikes available. And so this is right now live. Now, what other information can we gather from this data set? You know, that's another interesting question. So, whoops. If we look at what we can get the altitude actually. We can get the available docks, postal code, total docks, etc. It looks like we can also get the altitude, which is perhaps an interesting little tidbit of information. And it would be very interesting to see how that transfers over. So I'm going to do a similar thing. Use the altitude, plug into this information. And then okay, just to check. This is interesting. It looks like the altitude function we has was a little bit defunct, or the data may not actually exist. So I'm going back to the available bikes. So you can see that already. I can do kind of a basic representation of visualization using the city bike information. And the exciting thing about this is that this is live. So if we were to look at this video at a different time, then you would get a different sense of which points were highlighted in what way and where. Now I'm going to just briefly do a very similar thing with the gold as well. So I'm just going to isolate this downwards. And the gold prices I won't represent, but we can, we may have to do a little bit of a different thing here because our structure might be a little bit more complex. So if I examine what's in here, I think what I actually want is everything, and I'm actually going to flatten this just so that there's a lot of information above, and then datum, row 20 and onwards, I think is what we actually want. Because if I flatten this also, you can see that row 20 and onwards, our data starts to become serious, and we get actual information about gold prices and dates and so on. So what I want to do is I want to grab everything that is called datum and isolate it so that I can do something with it. So one thing that I actually can do is use the match component. And what this does is give in some text to match, and then text to find from, and then an ideal pattern. It will tell me whether or not something matched or not. So let's say, for example, I want to look for the phrase datum. So this is actually the text we're looking in. And this is the pattern that we're trying to match. And so if I see what's going on, I get a lot of true-false kind of determinations. So using the dispatch component, I can use that true-false component to then filter within this list. So if I plug in the values, depending on whether they're true or not, I get only the gold prices isolated, which is great. And now, since the gold prices seem to be interspersed with dates, I can use dispatch or a streamgate component. Not quite a streamgate component. I could use dispatch. I can use pick and choose, yes, which is also very similar. Or actually, sorry, pick and choose is the opposite. Sift pattern. Sift pattern, depending on pattern, will kind of slot a list of items into many different kind of different branches of different zones or different paths of flow. But that's not really necessary because dispatch does, at the basic core of it, does a similar thing or the same thing with a true and false pattern. It basically repeats a true and false pattern when there's no input into P, effectively dividing your data into one side and the other side. So we have dates and then gold prices here. And so now you can imagine that you can grab this information, and then because the API, the initial website that is giving you the information is not going to change its structure, then you can be operating with live data in order to do some further analysis. So that's kind of it for using APIs. Just to recap, you want to grab and find the API online. You want to get a URL, bring it into either a JSON or an XML parser, parse part of that information, and then you're ready to visualize it, represent it, use it within your tool. Oh, and one last addendum. Now you may ask, it's all great to find data of kind of existing more predictable data sets such as gold prices or even the city bike locations, but what if you want to gain information about something that does not have an API, such as, for example, the Columbia Course website or any other website? This process of grabbing data off of websites that were not meant to be are not structured like APIs. This process is called web scraping, or scraping data, and there are other visual studies that cover this process. But I'm just going to talk a moment about this new service that has recently been created that lets you scrape other websites very easily and very quickly. So, for example, I'm going to use the spring semester Columbia GSAPP calendar, and I will use it to scrape a website with this service called Kimono. And if I enter a URL, what they do is they offer this interface. Now, you may use Kimono, the service, you may use other services. The point is that the API or the information you're getting through the API is not just limited to that specific format. In general, you're dealing with all forms of data, and your goal is not just to find data that is given to you. You can also search and seek it out independently, and doing that through tools such as web scrapers, or in this case, this online web scraping tool. So, for example, I can do this thing, and I can click on check because I want all the courses. I want all the course titles. Yep, that's not right. But I do want that. So I'll call that course. I'll call that title. Yep, looks like I may undo a lot of things. Call this course. So I'll click on the course. That's all I want. Call this title. Click on the title heading, perhaps even this one. Do not want those other ones, but I do want these titles. That's great. Let's say I want the call number, my instructor. So click on the instructor heading. So you can see that the service is trying its best to be smart and intelligent about what information it's giving you and how. And you know, this is a service on their part, you know, but they've formatted it so that, you know, even though you're dealing with lots of irregular data and I'll have all these gaps, you know, they're going to try to format it together so it looks really well. Now it looks like I've missed, you know, visual studies, but I'm just going to do this as an example, so I'll click on done, and then I'll say GSAPP courses, and let's say I only really want to have it query weekly. So what services like this will do, or what web scraping will do, is now I get an API, and it looks like I can use a JSON. Use this URL to get this JSON file. So all of a sudden you can see that this is now formatted like this, which is really exciting because then I can go into Grasshopper, use that URL, and then plug it into this JSON component, and then maybe using one of these. You can see that I get a whole new series of information all in here. Now it's all in Grasshopper. Formatted really nicely, formatted very regularly. So all of a sudden in the span of a few minutes, 5 minutes, even less than that, I've gone from grabbing all the data off of the course schedule and bringing it in a regular format over here. And you know, if this website is updated, depending on how I've set up my API, this JSON file that I'm bringing in is also going to update as well. So that's kind of the magic of APIs, or even this service in specific that generates an API out of anything. So you can imagine you know, trying to grab stuff from the front page of the New York Times, or, you know, looking at Flickr's API, or making your own API, or scraping certain parts of websites in order to bring that data into Grasshopper. So with that, I think that covers pretty well how to use online APIs, or in the absence of an online API, how to start at the concept of scraping, either by using this METATOOL, or by exploring other ways, more serious ways in which web scraping can let you mine data.